Good day. I'm Martin Gagel with Market Radius Research. It's Thursday, March the 16th, and we've got President Alex Wylie of Allied Copper or Volt Lithium joining us today. I'm very excited to have Alex join us. It's a very interesting and compelling story with both a technology angle and a great business model with great partnerships. But please remember, this is neither a recommendation nor investment advice. We're here to learn about the company. Alex, thanks a lot for joining us today. And please tell us about Volt.
Well, thank you, Martin. I've got a presentation up on the screen as well that I'll be walking through, and feel free to interrupt with any questions or comments as we go along.
I will.
Okay, I'm just going to start off a couple of slides up. So Volt Lithium is, we established Volt Lithium about 18 months ago. My business partner and I, Marty Skase, we've worked together in the oil and gas industry for years. By way of background, originally I've been in the oil and gas industry for the last 15 years. And the assets that we have at Volt are very much aligned with the oil and gas industry. And I'll be getting into that as we go. The key thing about Volt and the assets that we've picked up is when we were originally getting along in our process, there was a couple of things that we really wanted to focus on. One was we wanted to pick up a large enough land position. Over the past, year, we've picked up over 435,000 acres in Northwest Alberta. We wanted to make sure that the lithium, or the brine-infused lithium, was part of the hydrocarbon-bearing zone. That was really important to us. We felt that the leverage that you've got by producing of the hydrocarbon-bearing zones is critical because you can use oil and gas infrastructure that's already in place. So when we picked up our assets in Northwest Alberta, we actually looked into getting into a strategic partnership, which we did last September. Again, that was really important for us, getting into the strategic partnership, because they had invested historically over $100 million in their infrastructure. So they're producing oil today.
Alex,
yes.
Sorry, and this is Cabot Energy, right? That's who we're talking about here?
That's correct. It's Cabot Energy.
Okay.
Yep. And I'll get a little bit more into the deal as go, but the main thing is that they're producing today. They're producing, their oil cut in the brine is about 10% or 90% water or 90% brine, and that brine is lithium infused. So for us, it was important to make sure that the infrastructure that's in place is what's being producing the brine today. So we don't have to spend a whole lot of money in infrastructure. So as we've been learning about our asset and really focusing on the technology side of Volt and the extraction process, we haven't had to drill a whole bunch of new wells. We haven't had to recreate the wheel from an infrastructure perspective. We're using infrastructure that's in place. The other thing that we really liked about the assets, and we did a reservoir analysis in the fall, we've got up to 78 billion barrels of lithium infused brine, and we've got concentrations up to 120 milligrams per liter. That's important to us because that's some of the higher concentrations in Alberta. And again, as I mentioned, the brine that's being produced today is lithium infused by our strategic partner. There are four key elements for us in terms of becoming a lithium producer. Critical at the beginning was obviously signing a production agreement. And again, as you mentioned, Martin, it's Cabot Energy. We had to have a reservoir that, in our mind, has enough brine and also has concentrations. We've satisfied that with the reservoir that we're going to be producing out of. Our technology is key, and I'll be getting into that more as we move through the presentation. But when we first got going on this, we took a view that in order for us to become a lithium producer, we've got to focus first on the technology, on the extraction technology. And so, we've spent the last year plus improving our technology. We came out with some press releases earlier in January where we were comfortable stating that we've been able to remove 99% of contaminants from the brine. That's important because we need the setup for removing contaminants before going into the DLE process. And then as we moved into the DLE process, we've been able to extract 93% of the lithium. And then the other thing that's really important for us is regulatory. Regulatory is key. As you know, in Alberta, there aren't any lithium producers today. And so, you know, the government's trying to come up with a framework to figure out, okay, how do we regulate it? How do we monitor it? But one of the key advantages that we've got is that because we're using existing oil and gas infrastructure, the regulators are saying, okay, we understand how oil and gas works. We understand you bring fluid to surface. They extract petroleum. We're going to extract lithium, and then you ultimately put the brine back down subsurface, and it's all in a regulated manner. So they understand that, and so we're not recreating the wheel by using the infrastructure we've got, and that's been a key thing to make us, you know, move ahead to be able to get approved for our pilot project. The production agreement that we signed. Again, I put this slide up just to give a sense of what the leases look like. And so, you know, they are producing today. They're producing oil and gas today. I look at this from two perspectives. One, obviously, the production agreement that's in place. So we're able to extract the brine from extract the lithium from the brine that's being produced today. They bring it up to surface, bring it into the facilities, we treat it, and then we put it back subsurface, which is all fully regulated and you know, completely standard practice. And
Alex,
again, yes,
right. They have their $100 million of infrastructure, and they've got their process systems there. Are you just one more sort of step? They sort of divert the pipe, they run it through your system, and then it sort of continues on through there, so it's sort of incorporated, or after they do their thing, you take the fluids and do your thing with it?
Yeah, and so that's a really good question, because originally, so it's going to be a bit of a hybrid. And I say hybrid because what we're going to do is we're going to focus on wells that have really high water cuts or brine cuts. And so what our original plan was that we were going to take brine that had already been basically the oil removed and treated and then use it through our system. We found that didn't work. And I think that's some of the issues that other groups that are in pilot production today have. What we're decided is we're going to take it from the wellhead. Now we will do a skim of the oil. So we're going to select wells that got very high water cut, skim the oil company gets the oil, and then we put it into their system and they treat it afterwards. So we think that the best way to go is actually treating the water before it goes through their facility, as opposed to after it goes through their facility. The challenge that you've got when it goes through the facility is they introduce other chemicals to treat the oil, and that affects our process. So we're going to go from the wellhead. Now we're going to use their leases, and we're going to add equipment to their leases to do the water treatment and lithium extraction process that we've got. And I've got yes.
Sorry, I'm going to interrupt again.
Yeah.
So you've got a large land package. Is that under the oil and gas leases, or did you sort of get a sub agreement from Cabot? So this is their land package, and you've sort of negotiated a deal to get the lithium off it, or is it separate from the oil and gas? How does the government sort of view those resources in the ground?
Yeah, so it comes down to extraction rights.
Okay.
And so Cabot has the extraction rights for PNG, or petroleum and natural gas. Yeah. We have extraction rights for all the metals. So they are two separate bodies. They are two separate permits, two separate leases that you ultimately do. So, I mean, and this is a bit of a misconception with some people, because sometimes the oil companies think that they own the water. They actually don't. The Crown owns the water, and we own various mineral rights. They're petroleum and natural gas, we're metals. So when it comes to production, though, we needed to come up with a production agreement so that we could utilize the leases that they have in place. So we own the metals, but we share on the leases with them. So
yeah, you had the right to the metals therein, but to leverage their equipment and their infrastructure, you still, unless you were going to drill your own holes or something, you then had to set up a commercial arrangement that was presumably beneficial for both of you to to get easy access to the metals. Is that right?
That's correct, and it's very relevant for the oil company. So the production agreement that we signed, we share in operating costs, and one of the biggest costs to operate, especially when your fluid levels are a little lower, is how do you handle the fluid? How do you handle the water, the electricity, and everything associated with it? So we're sharing in those costs with them. So we're actually dropping their ability to operate significantly, which helps.
Sorry, you're dropping their ability to not to operate, but their operating expenses. You're lowering their operating expenses.
That's right. So let's say their operating expenses are $30 a barrel.
Yeah.
By sharing in the operating costs, we can reduce them to $20 a barrel. That makes them more profitable. It does two major things for them. One is that by lowering their operating costs, we actually extend their reserve life, because the economic cutoff to produce a barrel of oil is dropped. So if they can extend their reserve life from, say, 10 years to 25 years, well, that helps them with their oil and gas reserves, but it also helps them with the retirement obligations. So when the useful life of a well is up, they have to reclaim it. You've got to basically put it into a natural state. If they can extend that period by 10 or 15 years, that makes a big deal for them. So they are really interested in working with us because we can extend their timeline for reclamation, and we can extend their reserve life. Now, what's really unique about what we're doing for them is, we believe that our reserve life for the lithium will be 100+ years. And so this is good from a number of reasons. The Alberta Energy Regulator likes it because, we are keeping the useful life of infrastructure in place. We're green, so we're producing lithium. We're using brine. Ultimately, it allows for a transition and use of this infrastructure to produce a green product, being lithium or battery metals. And the government benefits because they're going to be able to charge a royalty on our production. So that everybody really wins by us using existing oil and gas infrastructure.
And is the Cabot oil, and sorry, I'm not an oil and gas guy, so I this may be a dumb question or really obvious, but are these like shale fracking operations, or is this more traditional oil and gas extraction? Can you explain that to me?
The field originally is traditional oil and gas without fracking. There are some zones that you may do some fracking in. I think for groups like Cabot, they're really going to work with us. We're going to be producing, out of the hydrocarbon bearing zone. What we do by using our technology, or using our water production, we're actually going to increase the amount of water production. Now, as I mentioned, each oil well has about a 10%, each well of fluid has about 10% oil in it. So if we increase the production or the fluid rates, that helps us because we get to produce our lithium. It helps the oil company because it allows them to produce more oil too. And so everybody wins from it. So we're not really going after new wells. There will be some new wells, but we're going after existing wells in place. So there's no new real fracking or anything like that goes on with the process.
Gotcha. But they had been fracked previously.
The field's been in production for about 40 years. Originally, there was no fracking for it. There has been fracking in the last 10 years, but minimal. So they're basically looking at this. We're looking at it from the perspective of a reservoir. Again, we've got the 78 billion barrels there. We've got a lot of lithium below ground. There is some oil there too. So, it supports the oil company because they will keep their production, but it really supports us because of the lithium that's associated with it.
All right, thank you.
This slide just gives a sense of, where we are, the size of our land play. If you take a look at the land play, it kind of looks like we're going around sort of a circular area. In the middle is a caribou migration area. There's been a big study going on in caribou migration. Ultimately, we will probably fill that in to turn it into more of a square. And again, once the government finishes their study, we're happy with the land we've got. We've found really high concentrations in the reservoir, and again, we've seen up to 120 milligrams per liter. Again, for us, that's a big deal. If you look around Alberta, a lot of the other groups are sort of in the 75 range. Being up to 120 is very positive for us. So, and again, now in Alberta, in Saskatchewan, there's finding some high lithium concentrations as well. And again, as we learn more about the play, I'm sure we'll continue to find more high concentrations.
Sir, with the concentrations, you're taking the fluids, extracting the lithium, and then pumping the remaining fluids, which is basically just the water without some of the metals in it, back in. Over time, wouldn't this dilute the average concentration within a well? So in 10 or 15 years from now, call it 100 ppm, maybe goes down to 50 or something, and then I guess would the cost then increase in 10, 20, whatever years from now?
We don't think so. So effectively, the reservoir has about 78 billion barrels. For us to get into commercial production, we'll probably produce close to 36,000 barrels to start, probably increasing up to about 100,000 as we get larger, and maybe a little bit more. I mean, relative to the size of that reservoir, it's tiny.
Okay.
In fact, what we think is going to happen is that, if you look sort of where the higher concentrations are, we will actually dispose of the water more towards the east end of the property. And actually what that'll do is keep the pressure up in the reservoir and actually push the water to the well. So we keep our pressure up and we keep our concentrations up. Maybe after 100 years, we might start to see some communication, but it'll be a very long time. It's just, and again, we're at the reservoir is just so big, and we just don't think we're going to see communication.
Gotcha. All right. Thank you.
This is just a little bit about the geology. And again, there's 4 zones that have lithium infused brine. We're focusing on 2 right now: the green, which is the Muskeg, and then the orange and the pink, which is the Keg River and the Lower Keg River. And again, we continue to learn more about the reservoir. We are very comfortable that we've got an economic reservoir that we can produce out of. Technology partner. This is really important for us as well. So when we got started, I mentioned at the beginning, my partner, Marty Skase, he owns a company called Sterling Chemicals. And when we started thinking about the extraction technology, we had to look at it from a chemistry or extraction process first, mechanical second. So what we've been doing, again, for over a year, is we've been running, we've got a team of PhDs in chemistry, and we've been running lab experiments, lab tests, improving our process from the DLE process. This is just so important. I mean, the PhDs that we've got have got experience in reservoirs, they've got experience with oil field chemicals, they've got experience with ability to extract different metals from fluids. So we've spent a long time getting to where we have. We felt it was critical to come up with our own technology. And the reason why we felt it is important to have our own technology, all reservoirs are different. We're focusing on this one. I mean, when we look at even different parts of our reservoir, there are slight permutations to it. We have to have our team with our technology in place so that we can get the best results possible. And that's been a big focus of ours. We've got a lab up in the Nanotechnology Research Center up in Edmonton. And again, this is all critical as well. We're able to use state-of-the-art equipment to be able to come up with the process that we're dealing with. And again, when we're dealing with our extraction process, we're really dealing at the micron level and atomic level. We're not dealing at the millimeter size level. So the ability to tap into the Nanotechnology Research Center is absolutely critical for us. Which leads us, yeah.
No, keep going. I was going to ask about the technology, but you've got more to go through here.
Yeah, which leads us to, okay, where we're at and what we're doing. So what we're doing is a two-stage process. And so step one is brine treatment. And this is an absolutely critical part of the process. So there are things that will cause interference in the DLE process. And this is around the world, others have seen it. Elements like magnesium can cause interference. To a certain degree, calcium, sometimes boron. There's various things. We've got slightly sour water, so H2S. So we've got, we're subsurface, it's brine. So we have to treat it and clean it up. And so we spent a lot of time on step one. So we've been able to remove 99% of the contaminants from the brine. It's critical. Once we've got the water in the proper state to go into the extraction process, the DLE process works significantly better. So we developed a DLE technology to recover the lithium. If we didn't have step one, we wouldn't be able to get the 93% recovers. So again, the two steps work together, and it's really important because it's actually, I look at it as our technology is not just the DLE technology, but it's the process that goes through not only taking out the contaminants, but then removing the lithium. And this is just so important to what we're doing in the process. We announced in January, as again, we announced that we were able to get 99% of the contaminants out, and then, the recoveries that we received. This was all audited by Sproul. So it was nice to have the third-party validation and what we're doing. And that led us to the point where we said, okay, well, we're very comfortable because the testing that we were doing was not only in the lab, but it was also with our equipment suppliers' equipment. So we figured out the chemistry first, or the technology first. And the second part was to figure out, okay, how can we mechanically do this? And so what we've been doing for the last 6 months is spending a lot of time applying what we've learned in the lab to the mechanical side. And so we've been running tests, bench scale tests at our equipment suppliers facility for 6 months now. And again, when we put these numbers out, this is not only our lab, but it's also proven with mechanical equipment. What that led us to, Martin, is that we're comfortable enough now that we're going to go into pilot production. And pilot production is a big deal for us. It's important. We get a lot of questions, okay, you can do this in the lab or you can do it on a bench scale, but can you really extract low concentration lithium in scale? So we've announced to the market that as we move into Q2, we're going to go into a pilot project. So a pilot project for us, what that looks like is in stage one, we're going to do it at our equipment supplier's facility, and we're going to process up to about 250,000 liters of brine. So we want to do this level of processing because we not only want to show that we can extract lithium from brine, but we also need to show that we can do it economically. Because if you can't do it economically, how can you get into commercial production? So, we're thinking about the future, about how we're going to go into commercial production. So this pilot test that we're going to do is going to give us economics around what we're doing, show us that we can do it at an economic level, keep our costs low, and also make sure we've got all the right equipment to go into commercial production. And again, I'm going a little off script now about where we're at, but we've press released this. The pilot will give us the right equipment that we're going to need to use. And then as we move into 2024, into the second half of 2024, our plan is to go into commercial production. And so the equipment that we're using is so critical because the equipment that removes the contaminants, this is already commercial equipment. It's used in other applications in the oil and gas industry for treating water. And so they've got equipment that can do up to 10,000 cubes of water a day, which is 10,000 metric cubes of water a day. that's really important for us because as we go into production, commercial production 2024, stage one for us, and I'll just go. I'll talk about, and then I'll talk about our timeline at the end. Stage one for us is going to be about 6,000 cubes or 1,000 tons a year of lithium that we're going to produce. We think that it's important to start. Other groups are starting off building much bigger projects, starting up at 20,000 tons per year. We think it's more wise to go at 1,000 tons per year to start. Again, we want to get the right commercial equipment in place and then scale up. We also want to make sure that we understand how the reservoir works. Back to a comment that you made earlier, you're taking brine out of the formation, you've got to put it back somewhere. We got to make sure that we keep the pressure up in the formation so that we can keep our production flow rates going. So we're going to learn a lot in pilot, but as we move into commercial, we're going to do this in scale. What does 1,000 tons per year? Again, at today's commodity prices, you're cash flowing 30 to 40 million a year. So again, and it doesn't take us the amount of money that it would take others to get there. So again, it's a whole process that we've developed to get to the point where we can get into commercial. And then once we get to commercial, can we ultimately expand this to 20,000 tons per year? You bet. But we want to do it in a stage. We want to do it with far less capital, because by staging it up, you're using far less capital at the beginning. So you don't have to dilute shareholders at the beginning. And so we would rather get into commercial production, develop cash flow, build the value up, and then expand from there.
Your process, you've talked about the mechanical equipment to it. Do you use any agents or reagents or anything like that? Or is it, which then could then possibly create some waste issues? Or is it all a mechanical process that creates no new types of waste?
Yeah, so the equipment that we use, especially for removing contaminants, that doesn't involve chemicals, and that's so important for us. We use oxidization, we use electrocoagulation. There's a whole bunch of processes that we use, but we don't use chemicals. Because we have to get ourselves to get the brine clean enough so that we can go into the DLE process. We're taking contaminants out. We're not reintroducing new contaminants. When we extract the lithium, we take lithium out. So we're purifying the water quite a bit. Now we do use reagents to extract the lithium, and which everybody does. But what we do is that when we extract it, in the process of extraction, you basically you extract the lithium, and then you do what's called a hydrochloric acid wash, and the end result is you create lithium chloride at the end. So what the hydrochloric acid wash does is that it actually frees up the reagent to go through the process of lithium extraction. And so that's really important to us because we need to recycle the reagent. That drives down your operating costs ultimately. I mean, we're easily north of 100 times in terms of able to recycle the reagent, and that's a key thing that we're focusing on as we move forward. The more that we can recycle everything that we're using, again, the lower the costs, and ultimately the better it is for the environment and everybody.
All right.
This is just a slide about demand and what's going to happen over the next sort of up until 2030. I think it's fairly well known. There's no question that demand exceeds supply right now. There's a lot of talk about new mines coming on, a lot of new lithium production coming on. What I've seen so far, anytime you do a large project or a large mine or where you've got huge capital costs, it always takes longer. And so, there's been some talk, well, will demand and supply meet up? We'll have to see. Today, I'm not too concerned about it. I mean, the lithium price is very strong. Ultimately, I believe our operating costs to run production is going to be in around 5,000 a ton. And today, lithium's trading for north of 50,000. So even if it dropped to 20,000, we're exceedingly profitable. Again, this is just a little bit about where prices have been. There's been lots of talk about where prices have been. We've got very strong economics. And so if the price of lithium were to drop significantly, it wouldn't affect our project. Regulatory visibility, again, talked a little bit about that earlier. So critical. And this is such an important piece in my mind. What can hold up a project? Regulatory. Again, because we're using infrastructure that the government understands where extraction's happening, i.e. from an oil and gas perspective, they're very comfortable saying, okay, well, if you're just adding another step to the fluid movement, what oil and gas companies are doing, we're comfortable with you guys proceeding. As we move into, and the pilot that we go into will be critical from a regulatory perspective. They want to understand what we're doing as well. And so we'll be able to show the Alberta Energy Regulator results that we're providing, show that we can do things in a responsible manner, in a clean manner, in a green manner, so that as we move into commercial production, they'll be comfortable with our process. This is just our timeline. I've talked a lot about, where we're at right now, getting into pilot operations. We've done a lot to get where we are right now. And, we're quite excited to go into pilot production now. I mean, we've met all our milestones that we had targeted for ourselves during 2022 and the early part of 2023. And now it's time to actually start doing it and start doing it in scale so that we can get ready for commercial operations in the second half of 2024. We put this slide up just for some of the industry comparables. I think one of the things that about Volt versus some of the others is that we're not really well known right now. So we've done a lot to advance our business. We're just not very well known. Reason being, we did our merger with Allied Copper last fall. So we're called Allied Copper today. Volt is a subsidiary of Allied Copper, so it's confusing. We're going to address that by changing our name on April 20th to Volt Lithium Corp. We'll become more recognizable as a lithium company. And again, we think the way we're going to increase the value of our company is by showing results. And so we're very focused on results oriented. Let's get that pilot going. And then we're going to put economics around the pilot operation so everyone can see exactly what we're doing. And again, it's critical not only for the market to understand it, it's critical for us to understand it so that we can go into commercial production as we move forward. Commitment to sustainability, I mean, this is just critical. I mean, one of the things that is one of the outcomes by using oil and gas infrastructure is we're not creating a new footprint. So I showed the picture of the leases that we had at the beginning of the presentation. I mean, we're adding some equipment to the leases. We're not doing any further disturbance. And so, we're committed to removing contaminants. When we start putting water back subsurface, it's cleaner than when it came out. We're going to be extracting lithium. We're going to be upgrading lithium in Alberta. So, we're very focused on creating a sustainable company that has a minimal footprint as we move forward. And this is just a little bit about the team. Again, really happy with the team that we've got. I'll point to John McEwen, who's advisory board member. He also works for us. He's a PhD in chemistry. He's been really leading the team from a chemistry perspective as we build this out. We've done a ton of work over the last year, and now it's time to start showing what we're doing. So that's a little bit about lithium, Volt Lithium. And again, the concept is not complex. Fluids moving to the surface. We're going to extract lithium. We're going to put it back to subsurface. We're going to upgrade the lithium from there. And so we're going to prove to people that we can do it and prove to the world, prove to ourselves that we can do it economically so we can move into commercial production in 2024.
All right, that's great. The lithium you're going to produce, in what state will that be? Is it at the state where you could currently sell it at the $50,000 a ton level, or would it still need some upgrading to be in sort of battery production scale? How much upgrading after you're done with it would be required?
Yeah, so the product that we're going to produce at the pilot stage is lithium chloride. That is a marketable product, but it isn't the final product. Once you get it to lithium chloride, you can upgrade it. So we're talking with groups right now who can do modular upgrading. The plan for us is going to be to do modular upgrading to lithium monohydroxide, so we can sell an end product, battery grade product, to the world that needs it. I mean, there's a lot of discussions about, car companies, battery companies. Everybody needs, people want lithium produced out of North America, and so our target is to be, one of the first to do it and do it in scale as we start to move forward.
Processing it from lithium chloride to lithium monohydroxide, is that a known sort of relatively straightforward, easy process, or do you think you have some innovation to add to that step as well?
I mean, we'll see. It's a very straightforward process. Today, the product that we're producing, the concentration of lithium in lithium chloride is anywhere from, 10,000 parts per million up to 100,000 parts per million. So and the reason why there's a range is because we concentrate the lithium chloride. So we extract fresh water. There's water in lithium chloride, so we extract the water out so that we recycle it for our process. So, ultimately our goal is to get a even higher than 100,000 parts per million concentration. Very standard process to upgrade it. I mean, that's been done throughout the world. The groups that we're talking about from doing upgraders, again, they build commercial systems today to do it.
All right. And for almost or coming up to a year here, the US IRA, Inflation Reduction Act, with sort of Build in America mandates and so forth. Does Alberta or Canadian lithium sort of fall under that umbrella, or if you do the final stages upgrading in the US, does that make them tax incentives or eligible for made in the USA type designation? Or is that relevant?
Well, from what we've seen, it isn't. It doesn't matter. There's a critical mineral strategy that's a North American strategy. Yeah. And we're in discussion. We're starting discussions with the federal government. We're going to be starting discussions in the US as well with the Department of Defense. They want a North American solution. And we're a Canadian company, and we're going to be all Canadian. So, we're going to provide that solution to them.
All right. Just one last question, then we'll get to questions from the audience here. You're looking at commercial production, I believe you said in the second half of 2024. And you just raised some capital, and you're leveraging other people's infrastructure, so you've got less CapEx. Do you have sufficient capital to get to that stage, or what do you estimate the CapEx would be? And would that CapEx be suitable for like borrowing, leveraging from the banks and so forth as it's project financing? So I've thrown a lot in there. If you could just sort of talk about cash requirements.
Yeah. So the funds that we raise are sufficient to get us through pilot production and towards the end of this year. What we've been told by institutional investors, groups that are looking at potentially providing offtake agreements, is they said, we need to see what the results of your pilot are like. All groups have said, if you can show that you can successfully extract lithium from brine in Northwest Alberta, and you can do it economically, we're very comfortable putting money into you guys. So the amount of money that we're going to need to raise ultimately to get into commercial production will be about another 50 million. We believe
total capital, and then that could be divided up between some equity and some other non-dilutive sources.
That's correct. And we believe that there'll be a value change to our business as well when we get to that point. Yeah. I had a slide with some comparables in there. The group that's furthest along that isn't in production yet is a group called Standard Lithium. I mean, their market cap is easily north of 700 million. We're 24 million. They're in pilot production. They haven't produced a lot of results around their pilot production. I know they're working on it. we're going to have results around our pilot production by the end of Q2. So we think that, we're going to answer a question that a lot of people have. And that question is, can you extract lithium from low concentration brine? And we're going to show to the world that we can do it. And again, we've had discussions with groups saying, if you can show us that you can do it, we're happy to look at an offtake agreement with you. Show us what your capital costs are, show us everything that you need. So I'm not too worried about being able to raise 50 million after a successful pilot. I think for our shareholders, it'll be a meaningful change in valuation, which will be good for everybody.
All right, and we're going on to some audience questions here. Who is or are the principal shareholders or owners of Cabot Energy?
Cabot Energy is owned by a group called High Power, which is ultimately owned by iPulse. iPulse is a Robert Friedland company. So through the Robert Friedland group, they own Cabot 100%.
All right. Doesn't the inclusion of oil in the brine significantly increase the complexity and costs of lithium extraction?
Well, and that's where we talked earlier about we've got a two-step process. We have to get rid of the contaminants first. And maybe I should have been a little bit better explained, because we do remove all petroleum substances prior to going into our process. So we're getting rid of things like H2S, we're getting rid of magnesium, all the oil and gas that we would consider a contaminant is removed as part of step one of the process. So that first step is so critical so that we can move into step two, which is our DLE process. When we look at costs for extraction, the number one cost by far is the cost of the material or the media that we use to extract the lithium. That far outweighs, the removal of the contaminants, the electricity and everything like that. And so what we have to deal with is, when we're using that reagent or that media to extract the lithium, we need to be able to recycle it. And that's something that we've spent a lot of time on. The more cycles that we can use the reagent, the lower our cost it is to operate.
All right. There's a question here about the economics. You've addressed it. I'll ask the whole question and see if you can add any additional color to this. When will you know about operational economics? What are the upfront costs for infrastructure to get going at scale? Have any other oil and gas producers started reaching out and showing interest? I'm presuming in, the technology. And can you process in other fields as well? So there's all sorts of parts to that question.
Yeah, sure. So to start, for the pilot project, when we come out with the results from our extraction results from the pilot project, we're going to have economics associated with that.
All right.
And so we're going to be able to demonstrate and prove what our operating costs are. I mean, I believe, and again, what we originally budgeted last fall for operating costs were 10,000 a ton. Now that was before we had improved our technology of our reagents. Of that 10,000 a ton, we felt 6,500 a ton would be for reagents or for the media. We have significantly improved our technology since last fall, and so we think that that should drop materially. So my goal is to be in and around the 5,000 a ton to operate. In terms of, and I want to make sure I've got all the, I remember all the question. In terms of interest from other oil and gas companies, there's a lot of interest. Again, there's interest. The real interest will happen in my mind is when we can show that we can do this economically. And so this pilot, again, it comes back to the pilot that is so critical for us, because I want to have tangible evidence that people can due diligence, can look at and can say, okay, yeah, we understand your costs, Alex. This is what it looks like. Then the question becomes, is it applicable to other fields? We believe it is. What we need to, where we are at in our process, and because even in our field, there's some variability. And so, that's why we've got a team of PhDs in chemistry. I mean, we can look at a water analysis. We can look at the metals makeup, the contaminants makeup, and then we can decide, okay, what do we need to do in terms of our process? Again, the contaminants removal is just such a critical part to it, and that's where we focus a lot of our energy. Once you get the brine in a state where it's ready for daily process, it becomes, I'm not going to say mechanical, but for us, it becomes a little bit more mechanical because we've got the brine in a state where we can extract the lithium. A key point that I haven't mentioned, when I talk about the results that we've put out to date, you know, when we're talking about 99% contaminant removal and 93% extraction, we're doing that at a very low cutoff. So our cutoff is about 20 milligrams per liter. The tests that we did and that we produced press releases on were all at the 30 milligrams per liter. My view is I want to go after the really, really low cutoff. If we can extract at 20 to 30 milligrams per liter, it becomes exceedingly more economic when you get up to 50, 60, 100 milligrams per liter. So our process is at a very, very low cutoff.
I'm just going to go back to your two-step process here. So the first step is getting rid of the contaminants, which is such a big part of the battery industry. Having a little bit of magnesium or deleterious elements in there can just mess up a battery. Once you get that out, is it basically what you're left with is just water and lithium, and it's just an extraction or a concentration process at that point?
It's not exactly. So what we're trying to do by getting rid of contaminants is we're getting rid of elements that would interfere with the daily process. And so there's a lot of there's high salinities. There's still, you know, a lot of elements that are in the water. You know, but we removed all the contaminants that would cause interference with the daily process. So we don't have to get the water like pure. We just have to get it so anything that creates interference is removed for it. And whatever, like it's an element, it's on the periodic table. So, you know, we could look at a brine in, say, another part of Alberta or in the US, and we say, okay, we understand here's the makeup of the water from a, you know, what are the various contaminants in it. Once we understand what the contaminants are in it, then we understand the process of how to remove them. So again, anything that creates that interference, we remove so that when we've got the DLE conditions, we've got conditions where we can extract the lithium. Now, what happens is, so if you think about it from a brine perspective that's been treated, the contaminants are removed. The next step is, okay, we're going to extract that lithium out of the brine. So we're not taking that brine, we're actually extracting all the lithium out. And so that's where we're getting our 93% extraction results. So we extract out the lithium, and then we do what's called a hydrochloric acid wash, so to create lithium chloride. And for every process, the lithium chloride is the product that goes into the upgrading process, and that is a very pure product. So we don't have contaminants in that. So we don't have the magnesium, we don't have anything. So we've taken that lithium out and put it into a new format.
Gotcha. And I guess you've answered this already, but not directly. If you're a resource company or are you a technology company, it sounds like the ultimate vision would be to be a hybrid where you produce your own lithium directly through some of your own resources, but then you have the opportunity to license it or sell the technology out if and you could get tremendous economic scale out of that. Is that a fair conclusion to come to?
I would say we feel we have an opportunity, and we have an opportunity because there is a lot of lithium in brine, at least throughout North America. The challenge is it's in low concentration. We feel that it's better to have the resource in addition to the technology because you get more economics and more scale. I mean, ultimately, our goal is to become a large producer. And what we've shown is that, or what we believe is that for every 1,000 tons of lithium that you produce, you can cash flow up to 40 million a year. For us to go from 1,000 tons, maybe look at other plays in Alberta where you can, you know, add 2,000 or 3,000 tons or 4,000 tons in short order, you can scale up your cash flow very fast. We think that that's the best methodology. We think that licensing the technology, ultimately maybe, but I think we're going to create a lot of value keeping it proprietary and keeping it in-house. It's a real process that we've developed, and we think we've got a competitive edge because we can move faster than most.
All right. Okay. On to the stock side of things, will the ticker change as well as the name change?
It will. It will. And we're going through that right now. So we're going to be putting out our meeting materials next week about the name change. And then alongside of that, we'll have everything with the ticker change. Everyone will have a lot of advance notice about the ticker change and how the process works. And ultimately, there will be probably a transitionary period where you can buy it. You can try to go into CPR and it'll direct you to the new ticker symbol that we've got.
All right. And one last question here from the audience. Can your proprietary DLE technology be licensed to others in non-competitive industries to generate incremental future royalty revenues? Yeah, does it have application to other industries potentially?
It sure does. It absolutely does. What we've developed is a contaminants removal or purification and also extraction technology. And so could we apply that to different metals? We sure could. And we have other metals. We're focused on lithium today, but there are other metals. And, you know, that's, again, back to the team. If we didn't have the team of PhDs, if we didn't have the, you know, being in the Nanotechnology Research Center in Alberta, it'd be a lot more challenging for us. But yes, there are other applications that we could ultimately do.
What is your IP strategy? How heavily are you relying on patents versus just general know-how and skill? Because once you patent something, you kind of set at least part of it out into the world.
Well, and we're going through that with our legal counsel as we speak. I mean, the challenge is just what you said. If you patent everything, or at least put out a single patent, you just give your recipe to the world and people can reverse engineer it. So we're being very careful about how we're going to go about our patenting process during the future. I would say, you know, in terms of testing and experiments and runs that we've done, I mean, we've done thousands of tests. I mean, last week we did 50 different ones alone with our team. And so it's a very, very proprietary process that we've got. And again, it's not just about the DLE, it's about the entire process that's critical here.
All right. Well, I think we're close to wrapping it up here. We're almost into this an hour. And I always like to end this way. Could you just lay out over the next couple quarters here, what are the key milestones and maybe catalysts that investors should be keeping their eyes out for? You've got your pilot, you've got sort of name change ticker stuff. Sounds like you're talking to potential offtake partners. What kinds of things should we be looking out for?
Yeah, I think there are two main things that we're going to be focusing on over the next quarter. One is the pilot project, and that is the big thing that we're doing.
And that's
we
a
are
Q2 event?
Towards the end of Q2, that's correct. Okay. As we announced in our previous press release, the plan was to start early Q2. We are on track to start our pilot project on time, as we had said, and our plan is to produce results by the end of Q2.
And we're going to get little mild, like say when you start in the beginning of Q2, would you put out a press release saying, hey, we've started the process, or you're not going to say anything until you get the results of it?
No, we'll let people know that we've started the process, and then, you know, we're going to be running our pilot. So what we want to do is we want to make sure that when we put out results, once we've achieved, you know, the pilot, we want to make sure we've got fulsome results for people. We want to make sure that it's been audited. The plan is to have everything audited by a third-party engineering firm. Everything's third-party verified. So, you know, there's the actual pilot, and then there's the audit and the verification of everything that we're doing. So we want to have a comprehensive package. We believe this is going to be extremely meaningful. And again, not only for our shareholders, but also for, other potential oil and gas producers that want to maybe look at, what do you do with lithium extraction, for governments, for all kinds of groups, for the regulators. So we really want to make sure that we get this right when we put our results in.
All right. And so beyond the pilot, any other things to look out for?
I mean, as we move into the back half of the year, we're going to be looking to transition from pilot and going into commercial. There will be keeping shareholders up to date in terms of how we're progressing along our process. I mean, ultimately, at some point, we're going to need to raise some money, but we're not going to do anything until we've got a proven pilot showing economics, because we think there's going to be a step change in valuation as we get to that point.
With the other companies, there was PEA comment and feasibility studies. Are you going to be providing any sort of official sort of documents like that, or there's no legal requirement that you need to, you could just go straight into production, or will any of those steps be taken?
I mean, we will be putting out a resource report in Q2.
Okay.
When it comes to things like a PEA and a pre-feasibility study, effectively what we're doing by putting out our economics analysis, that's really what a PEA does. I guess what's a little bit different from us to a traditional group that puts out a PEA is we're going to have live results from our pilot for our economics. And so we took the view that we would rather have live results, live economics based on what we've done as opposed to what we're going to do. And so when it comes to a PEA or a pre-feasibility study, ultimately, we'll just have to make that's the typical path you go, obviously, with a mining company. If it's required a pre-feasibility study, we will do it. I guess what's a little bit different from us, from say a traditional group that puts out a pre-feasibility study, is the economics required. I mean, to get into commercial production, it's just our capital requirements are just so much lower than if we had to do a full mine build out prior to actually going into commercial production. So we're taking a staged approach. We think that's the right approach. As we get into commercial production, we're going to go through a lot of expansion. I could see at that time being a pre-feasibility study for expansion, because then we're going to do step change in capital. But by then, we will be well along the path in commercial production.
Okay. Well, with that, I think we should wrap it up here. Alex, thank you very much. There was a ton of information there. Very, very interesting, very dramatic changes and impact you could be making here in the next little while. So thank you very much. Appreciate the conversation, and I look forward to hopefully chatting with you in the future and getting updates as things progress.
Thank you, and thank you for your time today, Martin. It was a real pleasure.